All right, ladies and gentlemen, we are now in 3-2, and we are just going to expand on what we did yesterday. We're going to solve two-step equations. I'm still going to continue to show the examples in a vertical manner because I think that is A, how you'll see it at high school, and B, it just tends to make more sense to students, and I want you to see it that way. In a two-step problem, it's really no different than before. You have to ask yourself, how are things connected, and then how do you kind of undo that mathematically? So if you look at this problem right here, you can see that there's a 7 that's been added, and then the x has been multiplied by 3. I always think of it like these two are closely matched, so those will be the last to separate. So your first move would be to subtract the 7 because that's the mathematical opposite of the adding. And then the second move is going to be to divide by that 3 because that's the mathematical inverse of the multiplication. So if I was going to solve this, and I'm just going to write it off to the side again, I'd have 3x plus 7 equals 19. I'm going to draw my tracks in so I make sure I keep the two sides separate and balanced. To get rid of my plus 7, I use a minus 7 on both sides. That brings this side to 3x and this side to 19 minus 7, which is 12. So that is my one step. Now my my second step is going to be separating these two. Since they are attached by addition, I just go ahead and separate them through division. I think I said addition, multiplication. So anyway, x equals 4. And just like yesterday, and just like always with solving, I can check my answer. I can go back to the original problem up here, and I can look at what I have, and I can put a 4 in where the x was and then check to see if that actually works. So now we're back to PEMDAS in earlier chapters. That will be 12 plus 7, which is 19, which clearly equals 19, so I can check that that has been done properly. Looking here, it's asking me to solve these two-step problems. So again, I'm just going to look and see whatever's attached to the r over here, that's going to be the last thing to leave. Same thing here with the k. So in this case, the first thing I'll do is get rid of the 12. Since it was subtracted before, I'll have to add to get to detach it or get rid of it. So then all I have left is the r divided by 4, and over here, these two go together to become a 7. Now, this r is divided by 4, so to undo that division, I'm going to multiply this side by 4 and this side by 4. So my last step lands me at r equals 28. I can go back up here, grab my calculator, and do 28 divided by 4 minus 12. That will turn into 28 over 4 turns into 7 minus 12, which will equal -5, and that checks with what I was supposed to get. On this problem to the right, again, the 7 will be the last thing to separate from the k, so I need to get rid of this minus 14 through addition. Gone there. 7k will equal, and I'm staying on each side of the tracks, this will turn into a 56. Since the 7 is multiplied by k, I'll get rid of it through division on both sides, and k will equal 8. Going back up here, I can grab my calculator and see, does 7 times 8, putting that in for the k, minus 14 equal 24? And it does. All right, so this one still has two steps, but the two steps are a little bit different, because the variable that I'm trying to solve for is in both parts. So now we're going to be going back to what we've done in the past, which is combining like terms. And so you're going to put them together before you can do anything else. So 4a plus 3a equals 63. I'm going to go ahead and put these together. And since 4a plus 3a gives me 7a, that is what the left side of my equation becomes. And so then, just hang on one sec, sorry. 7a, and then this will be equals my 63. So that's my one step. Then to go ahead and do my second step, I need to get rid of this 7 that's multiplied in. So to get rid of something that's multiplied in, I use division, and a equals 9. Then I can go ahead and check by taking my original problem and putting in a 9 here for the a, and a 9 here to see if it does actually come out to be 63. This is going to be 36. This is going to be 27. That's going to add up to 63. Awesome. So let's try these two. Same kind of thinking. Get my tracks here. I notice they both have z's. So 5 plus 4 will give me 9z equals 36. The 9 is multiplied in, so I divide it out, and z equals 4. Over here I have a subtraction, but I don't do it any differently. I still just go ahead and combine them. So 5b minus 2b leaves me with 3b equal to 9. Since the 3 is multiplied in, I go ahead and divide it out. So b equals 3. And keep in mind, you can always check each of your answers. Okay, so this one, the wording and everything is kind of tricky. So what we're just going to do is focus on the problem itself. The main difference is we have to write our own equation. So the output we're going to call y, and then the input we're going to call x, just like we did with our function practice. So the output, which is y, of a function is where the equal sign lands, 2 more than 4 times the input. So if you have 4 times the input and you add 2 more, that's what those words are going to look like as an equation. So when it tells you to write the equation, that's where we're at. Now it's just like the other problems we've been doing. When it says to solve the equation when y is 14. So we're going to put in a 14 here and work backwards to find out what the x equals. Keeping in mind that the x and the 4 are connected, so those will stay together till the very end. We have to get rid of the plus 2 by using a minus 2 on both sides. So 12 will equal 4 times x. Now they're going to separate since they're multiplied together. They'll separate through addition, and x will equal 3. Okay, same thing in this last one. We're going to go ahead and try to figure out output's going to be y is going to be equals 3 less than 6 times the input, which is x. So my equation will be y from the output, is, so that's going to give me an equals. And then I have to think 3 less than 6 times the input. So I have 6 times the input, and then 3 less than that would be a minus 3. So that's the problem that I'm trying to solve. And then it says, find the input, which is x, when the output is 15. So they're telling you y is 15. So I'm going to start my problem by putting a 15 where the y was. Then I'm going to go ahead and solve. These two are connected through multiplication, so they'll separate last. I add 3 to both sides. 18 equals 6 times x. Since they're multiplied together, I separate them with division, and x equals 3. Awesome. So check the daily plan for what your assignment is, and look back at any of these that you might need help with.